And in this episode, we are going to make the erupting lava wood flip. In this process, we mainly focus on the source of the lava, the control over the shape of the lava by some force fields and noise, meshing, and the rendering. The meshing and the rendering are very easy to be done, and the lava source is created in the same way as the debris source. So the key point in this episode is how to get good dynamics with force fields in dub. Okay, let's get to it. Import the shattered terrain. Okay, let's make the lava source first. Add an unpack node. Transfer the name attribute to it. Delete the static fragments. Scatter some points by density on the inside surface. Uncheck the unwanted parameters. We can see a yellow exclamation mark here, which means the number of particles exceeds the maximum number set here. Disable the max points. Drop a debris source. Still, delete the unwanted nodes. We import the animated points of the fragments. Let's check it. Okay, if the points keep static, you can check if they have the name attribute. If not, you probably forgot to transfer the name attribute to the unpack node. The solution goes well, but the number of the particles is a bit too small. Let's bring up the search radius. Okay. Create a dub network and get into it. Create some necessary nodes first. Select a preset, source flip. There is no surface field, so I don't need it here. Delete the group here. Remove the path here. Set the visualization to particles. Let's check if the particle source is read correctly. Nice. You can change the display color if you'd like to. Lower down the simRes in dub for a faster simulation, which is fine for the beginning. Change the max substeps to 1. Though the details are reduced, the simulation speed will be doubled, and it's totally workable for the current shot. Set the velocity transfer to APIC. This way the fluid will be more clustered than in the default fluid mode. Our lava is of high viscosity, so the APIC mode is a better choice. Next, we set the fluid container. I'd like to start with the bounding of the fragments at the last frame and adjust it somehow to get a final container. Copy these two nodes. Drop a timeshift node and freeze the animation at the last frame. Add a bound node. Most of the fragments are on the upper part of the container, but there is a large empty space below. Display points. You can see there are some scattered points. Add a blast node to delete them. Okay. The lava will erupt in this way and go up and down. So we increase the size of the container as needed. First, the positive z-axis. Then the positive y-axis. And then the negative y-axis. Expand it downward somewhat. Besides, some lava will also go forward, so adjust the container accordingly. The negative x-axis and the negative z-axis don't matter, since the lava there cannot be seen. So it's fine even if the container is not big enough. So just expand a little bit. Let's link the container to the one in dub. Then we set up the collision object, the same as the one we used for making the smoke generated by the volcano fragments. OK. Then the lower static terrain. We can directly copy the nodes in dub that we've already created. Drop a dub.io node. We are only working on the lava without foam simulation, so only particles are needed here. Then drop a group delete node to delete other groups because we don't need them when meshing, and we can also save some disk space. Also delete the useless attributes. Only keep V and P-scale. P-scale will be used for meshing. V will help us add motion blur in rendering. Drop a file cache to cache it. It's done. Let's drop a wrinkle node and set colors by the velocity for a better observation. Currently, the ramp is of flow type. Delete it. Type in vector here. Now a color bar appears. Select a preset, black body, and adjust the display range. It's fine as long as we can view the lava well. Well, there are some issues to be fixed. Display the terrain. One thing is that there are so many particles inside the fragments. This is a total waste because they will be invisible after rendering. Another is the distribution of the lava is not good. From the top view, the terrain is covered regularly. Actually, I want most lava here and some on the right, and a little lava here and here. Besides, there are a large number of particles inside the crater, yet they cannot be seen actually, so we need to delete them. Okay, let's first deal with the particles inside the geometries of the terrain. I'm going to delete them after the source creation so that the source can be deleted too. Convert the collision objects to polygons. Drop a group node. Use the right input to select the particles. Then drop a blast node to delete them. Update the viewport. An empty group is produced here. Tick this checkbox to delete it. Next, I'm gonna remove a part of the source manually. Still drop a group node. Add a sphere. Enable the point snapping. Disable lift then. Box up the points inside the crater through this sphere. But points are over-selected, so I'd like to use soft transform to deform it. Enable select visible geometry only. Shrink the sphere here a bit. Increase the soft radius. OK. Make a copy of the soft transform node. shrink the sphere here. The selected range is still kind of large. Let's try to lower it a bit. Next, we can add some more spheres to exclude the unnecessary areas. Here, I directly use the nodes that I've already set up. As you can see, I deleted the points here and here for a better lava distribution. Yet some points in the intersections of these spheres were not deleted correctly. Let's fix it. Drop a Boolean node and perform Boolean operation with the merge itself. OK, fixed. Both intersect and union can do the job. OK, we're done with the adjustment of the source. Let's take a look. It doesn't seem to be working. Well, I forgot to delete those points. Perfect. Let's move on. Get into DOP and check if something can be optimized. Uncheck receding particles. It's not necessary in this distance shot, and we can save some simulation time. Then let's add gravity. Directly copy the one made for the terrain distraction. This way the dynamics can be well integrated into the scene. OK, let's cache it again. Alright, let's take a look at the lava. The distribution and the form are better, but it's too fragmented overall, and it spews out too far, which looks out of proportion to the terrain. Meanwhile, it slides down along the terrain. Actually, these problems are caused by low viscosity. If it's increased, the lava won't be so fragmented and it won't slide on the terrain. Instead, it will stick there. Okay, let's get to it. Check Enable Viscosity and Viscosity by Attribute. Set the Mix method to multiply. Set the viscosity to 1. OK. Here we need to create a viscosity attribute. The viscosity of lava depends on its temperature. The higher its temperature, the lower its viscosity. Gas temperature update can generate the viscosity attribute by temperature, and it can be read by flip solver. Lava tends to cool down rapidly in the air, so set a slightly larger outer cooling rate. OK, let's create a temperature attribute in SUB before creating the source. We can either assign a constant value with an attribute wrinkle node, or assign a flow value with an attribute noise node. The attribute noise can bring some variations, but they won't make much difference to the final effect. So I prefer setting a constant value. OK, let's cache it again. Alright, I cached 4 versions for comparison. In the first simulation, the temperature is created with an attribute wrinkle node, and the cooling rate is 0.53. We can see the lava is not as fragmented as before, and sticks on the terrain well. Nice. Let's look at the second one with the attribute noise. Let's make a comparison. Not much difference, so it's not necessary to add noise. The last 2 simulations are with a different cooling rate. This one is 0.53 and this one 0.25. The particles are colored by the temperature attribute. There is almost no difference in the shape. Yet the third simulation with a cooling rate 0.53 has a more rapid temperature change. Then the lava will have a richer color change when we shade it with the temperature attribute later. Alright, let's figure out the problems to be fixed. As for the issue that the lava is spewed too far, we can try a drag force. Another problem is that the lava is a bit too less. I hit the terrain and made a flipbook. We need spewing lava, but there are a large number of particles on the terrain. I also made a flipbook with a source on it. We can see the source exists all along. That's why the lava keeps spewing out. I'd like to set the source spewing for a second. Drop down an attribute wrinkle node. We make the particles disappear gradually, otherwise the dynamics of the lava will look strange. The rain function returns values between 0 to 1. When I change del to 1, all the particles disappear. When it's 0, all the particles are there. Let's keyframe del. At the 10th frame, keep all, and delete all at the 30th frame. Keep the curve ease in and ease out. This way the dynamics of the lava will be natural. Alright, let's make a flipbook. Looks good, just the amount of particles is much less, so let's add some more. Increase the search radius to generate more particles. Meanwhile, we can add a particle replicate node after the source. Set shape to line to imitate trails. Bring up the uniform scale. Currently, the direction of the lines is a bit too messy. Let's check the attributes. There is a normal attribute and a velocity attribute. This node can inherit both of their directions. If they both exist, the direction of the normal will be inherited first, which is not what we want. We want the particles to go along their trails, that is, to go along the direction of the velocity. We can simply delete the normal attribute with an attribute delete node. Yet, I'd like to solve it earlier. Come up here. Many attributes were generated when we scattered the points, but we don't need them except for the name attribute, so keep it only. This way there will be no normal attribute. Now the direction of the trails is organized, but it is still not right. Let's modify it further. Change this value to -0.5. Set the orientation to ZX plane. The noise tab here. Take Add Noise to curve the trails a bit. Move these two nodes here. The newly generated particles will also be inside the fragments, so put them before this group node. Alright, let's cache it again. Okay, done. We can see there is more lava spewing out and less on the terrain. Nice. Next, let's add a drag force. Link it to the particle velocity. Let's see how it goes. I paused caching since I realized the force was too strong. The lava cannot even erupt. Let's lower down the drag. It's still too strong. Lower it down a bit more. Cool. The distance and the range of the lava eruption are good and is integrated well with the debris. But the lava eruption is not that explosive. I'm gonna give it a high speed at the beginning and then let it slow down gradually. This way the eruption will be more powerful. Okay, drop a point velocity node. Select from attribute and set the attribute to V so that the current velocity can be inherited. But this force shouldn't be there all along. Fifth function helps here. From the 5th frame to 30th frame, set the force from 2 to 0. Display the velocity lines, and then make a flipbook. Okay, it works. Let's cache it again. Oh, one thing needs to be done before caching. As you can see, the lava becomes black when colored by the temperature attribute. This is because no attributes are inherited here. Let's adjust it. Keep the temperature and velocity only. I cached a small part and found the force was a bit too strong. Let's lower it a bit. Cache it again. Now the explosive force is nice. Just the lava goes too far in the latter time. It's good in the first 60 frames, but it gets worse after the 70th frame. Here we can make the drag force stronger slowly. Still use the fit function. From the 25th frame to the 70th frame, make it stronger gradually. Alright, let's check it out. Looks good. Okay, done with the rough lava. We can see there are no details, just some smooth strips. Let's get to it. Droplet gas disturb. The third input of the flip solver can update the velocity of the volume. Drop a box as a scale reference. Enable the point snapping. Now it's too small to be seen. Let's scale it up a bit. We can imagine how this strip will be with this large noise. Then we will know if the size is proper. Set a mode to block-based. Type in the size. This is a large scene, so we'd better start off with a relatively high strength, or it won't be effective. Let's try 500. Check it out. The gas disturb node works, but in the latter part it is obviously too strong. At the beginning it's a little bit weak. At around the 60th frame, it works well. Based on that, we can keyframe the strength, make it a bit stronger at the beginning, and get weaker with time. From the 15th frame to the 60th frame, set the strength to 700 at the beginning, and make it weak gradually. Set it to 60 at the end. A little bit is fine. The lava is disturbed properly at around the 60th frame. But after we set a larger strength at the beginning, the lava will come to the current state earlier. So set the end frame to 40. Let's cache it again. We can see the gas disturber works well all along. Next, we use gas confinement to add some smaller details. Let's try this function first. Check how it comes out. Oh no, it explodes just at the 8th frame. The confinement scale is too strong. We lower it down. Still too strong. We adjust the visualization range to view the details. We can see the lava is terribly out of shape. Let's reduce the confinement scale a bit more. Okay, let's make a comparison before and after adding the gas confinement. Lower it a little bit more. Alright, let's cache it out. Good, and the details will be reviewed more when we set a higher simrest later. Alright, let's go on. The lava still goes too far at the end. Let's fix it. Lower down the velocity of the source and bring up the strength of the drag at the end, 0.0035, and take down the particle separation to 1.5. Before caching, we still need to add the rest attribute, which will be used when we work on the shader. Drop down a rest position before the debris source, since the position of the points can be changed by this node. Generally, fluid simulation have 2 rest fields. 1 rest will do in this case, since the eruption just lasts for a short time. Also, we can save some hardware resources. Get into DUB and check Add Rest attribute in the flip solver. Remember to output it. Let's cache it out. Okay, done. Perfect. So we're done with the DUB simulation. Next, let's focus on meshing. 2 nodes can do the job. Here, I'd like to demonstrate how to do the mesh conversion with them and their pros and cons. Okay, let's start off with this node. Make the particle separation consistent in dot. It's kind of slow to display the entire flip, so let's drop a box and group a small part for testing. Drop down a blast to isolate this part. Show the terrain as a scale reference. Let's first lower the droplet scale a bit. I don't want the small VDBs to fuse too much, so lower the influence scale. Currently, the VDB is of too low res. A lot of voxels are not converted properly. We lower down the voxel scale. Let's convert it to polygon. Bring down the particle separation a bit more. This effect is not good enough. Let's try to add some particles. I'm not gonna modify the dop settings here. Instead, we can use this node. No need for so many particles. Now the mesh looks better. Uncheck Add Noise here to prevent flickering. Inherit all the attributes. The lines are too long. Reduce the uniform scale a bit. Okay. We can see the ratio between the small VDBs and the fragments of the terrain is good. Actually, the smaller the small VDBs are, the larger the fluid amount will seem to be. I think the current look is good, so let's cache it out. Cache from the 50th frame to the 70th frame. Okay, done. It takes 1 minute and 47 seconds. Let's try this node. Also set the voxel size to 1.5. Reduce the mean radius a little bit. Okay, increase the res a bit more, and lower down the point radius scale. Convert the VDBs to polygons. The res is still kind of low. We lower the voxel size a bit more, but VDBs don't look like real fluid. We add a VDB smooth node. Looks nice now. Alright, make a flipbook. Okay, let's make a comparison. While a display error occurs, let's switch to another light and then back. Compared with the previous version, it has fewer details. We can try a smaller iteration. More details appear. Then drop down a peak node to shrink the VDB inward. Adjust the distance here, but make sure there is no face intersection, otherwise some flickering will appear. The VDBs are not as thick as before. Nice. Alright, let's cache it out. Okay, it only takes 1 minute and 4 seconds, much faster than the previous cache. But we can see this mesh is a bit smoother, and it's not as natural as this one. So you can choose either one as needed. This is a distance shot, and we don't need too many details. This one is good enough for this project. When doing the final caching, we need to increase the adaptivity to optimize the mesh somehow. You can see when it's 0, the amount of polygons is very large. Currently, the mesh has no attributes. Let's transfer the attributes to it. Drop an attribute transfer. we need rest, temperature, and velocity. Then drop a color node. And tend the lava with the temperature attribute. The color transition is not very smooth. We can take up the max sample count to 5. Disable these two nodes and cache it out. This process will take around 2 to 3 hours, so I don't cache it again. Just use the one I've already done. Alright, let's switch to the render viewport. I have imported the fractured terrain, the lower static terrain, and the lava. Drop a material builder. Assign it to the lava. Then drop down a principled shader core. Import the temperature with a bind node. Then use a reamp to remap the color of the lava. The lava belongs to an illuminator, so link it to emit color. Disable the gradual refinement rendering to speed up. Okay, let's adjust the color of lava. Select a preset, black body. Shift the yellow to orange a little bit. The colors look kind of dark overall. Adjust it somehow. Set the interpolation to B-spline. Currently, the reflection is a bit too strong. Lava is an illuminator. Its reflection should be very weak. Here, I directly remove it. We can see the lava is still a bit white. This should be caused by the diffuse. Let's darken the base color. The lava is still a bit too dark. Let's drop a multiply constant node. Set the multiplier to 4. Next, I'm gonna use a turbo noise node to vary the brightness for some details. So here we need to import the rest attribute with a bind node. Select vector here. Connect it to emitter for an intuitive view. The frequency is too high. We reduce it. Okay, multiply it by the lava. Well, it's darkened again. Let's lighten it. The shader looks good at the end. Let's check the lava at the beginning. It's a bit too bright and lacks some variations. So we drop a fit range on clamped node, which won't clamp the color range. Better now, many details appear. We'd better get some details when rendering in Houdini. It will be conducive to further adjustment in compositing. If the lava is exposed in Houdini, it will be hard to extract details later. Okay, we keep this brightness at the beginning and the previous brightness in the latter time. Let's make an animation. Still, use fit function to remap the source max. From the first frame to the 150th frame, set it to from 2.5 to 1. Alright, that's it for the lava shader. See you next time.